Almost everyone who takes a middle school science class memorizes Newton's second law of motion. Force equals mass times acceleration, but the traditional way of teaching it creates a logical loop. We measure acceleration to find the force, then use the force to calculate the acceleration. It feels more like a human-made dictionary definition than a law of nature. To find the physical content hidden inside this equation, we have to ask a ridiculous question. What if the universe utilized a completely different mathematical formula? By testing impossible physics and seeing exactly how they break, we can reveal the hidden assumptions and quiet brilliance of the reality we actually inhabit. Look at this diagram comparing our real world to a hypothetical universe governed by F equals mv, force equals mass times velocity. If the universe ran on F equals mv, the initial velocity of any object would be entirely dictated by the configuration of the matter and gravity surrounding it. Our everyday experience contradicts this. When you throw a baseball, the environment doesn't lock your speed. You have the freedom to decide exactly how fast that ball leaves your hand. In our universe, an object's starting position and its starting velocity are free variables. You can place a ball anywhere and throw it at almost any speed. As this visual hierarchy shows, if position and velocity are freely chosen by us, the universe's controlling forces must dictate the next level up in calculus. That leaves acceleration as the output controlled by the universe. Acceleration is the lowest derivative that leaves both position and velocity as free variables. While a higher order law based on jerk would also work, it would require even more initial conditions to be set. F equals ma is the leanest possible mathematical code for a universe that permits choice and movement. Now look closely at the left side of the equation. The F for force is an audacious claim about how nature works. It asserts that the entire configuration of all matter, gravity, and fields in the universe can be compressed into a single, measurable output vector acting on a test particle. By isolating the m in this diagram, we see it acting as a physical bottleneck between that universal force and the resulting acceleration. Mass represents the fundamental scalar constant of an object's pure resistance to the universe trying to move it. The equation acts as a translation mechanism. The universe's total configuration pushes from one side, the object's intrinsic resistance fights back from the other, and the resulting compromise is a specific change in the object's path. But there is a boundary test that breaks this perfect translation. We have to ask what happens when our viewpoint is no longer stable, but is actively accelerating or spinning. In these non-inertial reference frames, Newton's simple F equals ma falls apart. The math stops matching the physical reality of what we see. Look at figure 31.1 in this schematic, mapping a stable reference frame against a moving one. Dropping to equations 1.13 and 1.14, we see the mathematical hack, injecting fictitious forces to make the failing equation balance again. This diagram showing a rotating globe illustrates exactly that. Commonly known phenomena like Coriolis and centrifugal forces are not physical objects, they are mathematical ghosts, patched into the math to save Newton's law on a spinning planet. F equals ma relies entirely on the assumption of a stable, unmoving observer. Place that observer into a dynamic, spinning universe, and the law reveals its fragility. Pushing the equation to its ultimate limit, nearing the speed of light, requires us to look at relativity. At relativistic speeds, the mass of an object is no longer the simple, reliable scalar number that we measure here on Earth. As this animation demonstrates, mass transforms into a directional matrix. The force applied to an object and its resulting acceleration vector actually bend out of alignment. The physical consequence of this is highly unintuitive. If an object is moving near the speed of light, it requires far less energy to accelerate it sideways than it does to push it further in its current direction of motion. That simple m we rely on is an illusion of our low-speed everyday life, acting as a mask over a much more complex relativistic reality. There is a historical twist to all of this. On the title page of his Principia Mathematica, Isaac Newton didn't actually write F equals ma. He wrote his law based on momentum, describing what he called the quantity of motion. Watch as the familiar text morphs into the unmodified equation. Force equals the rate of change of momentum over time. written as F equals dp over dt. As long as a specific object's mass remains exactly the same, the calculus in this momentum equation simplifies perfectly back into F equals ma. F equals dp over dt is the foundational version of the law. It survives the extreme physical tests exactly where F equals ma fails. We require that momentum-based framing for massive systems that lose mass while they move, like rockets actively burning fuel to reach orbit. F equals ma survives as a functional approximation, precisely governing the slow, heavy mass world humans inhabit. While we possess the free will to choose where we start and how fast we go, the universe uses this specific law to flawlessly dictate the exact rate at which our path changes.